Looking up at the moon, you might think that it's relatively benign, maybe a nice place to visit. Maybe you wonder, as you stare at its cratered face as it drifts across the night sky, why we haven't been back since Apollo 17. Well, that's exactly what we're going to find out tonight. I'm Eric Malachite, author of Echoes of Olympus Mons, and this is Science Get. There's a good reason why we're cautious about lunar regolith, or moon dust. During the Apollo missions, the substance got everywhere. Inside the lander, on the suits, beneath the fingernails of astronauts, in their eyes, in their lungs, caused equipment and computer failure, and most troubling was how it wore down the protective layers of the astronauts' suits over time. It also easily picks up an electrostatic charge, if it doesn't already have one because of the constant bombardment from charged particles from the solar wind. By the time the Apollo program astronauts finished their mission and were ready to return home, the moon dust had worn their boots down to such a degree that there was a risk of a complete breach in some of their suits. Lunar regolith is like sand, but since it's constantly blasted by charged particles by the solar wind, it's as fine as glass, and it carries a slight magnetic charge from constant exposure to the solar wind, meaning it sticks to everything. Regolith covers nearly the entirety of the moon's surface. Bedrock is only visible on the walls of craters. Scientists believe that this moon dust was created by uncountable impacts from meteorites. It was feared this lunar dust would be too light to support the lunar lander's weight at the beginning of the Apollo program. Fortunately, robotic surveyors showed that the lunar surface was firm enough to support a landing spacecraft. Later, astronauts observed that the surface of the moon felt very firm beneath their feet. With NASA's current plans to return to the moon in the near future, the question becomes, how will they deal with the challenges that lunar regolith presents? Well, it's not just the moon that we'll have to consider when it comes to that. Mars, a source of constant fascination by people dreaming of humanity's inevitable ascension to the stars, is covered in the stuff. Astronauts would be forced to contend with Mars's dust just as the Apollo astronauts did. And what's worse is that they won't have the benefit of being close to home if the dust manages to damage their suits, gets into their lungs, or the systems of their gear, let alone their landers, shelters, and other equipment. Looking beyond Mars, any celestial body in our solar system that doesn't have a significant atmosphere and is exposed to the solar wind will also have regolith. This includes many of Jupiter's moons and asteroids that we may wish to land on. Larry Taylor, a distinguished professor of planetary sciences at the University of Tennessee, has an idea of what we can do with regolith. He's one of those strange people who likes to stick odd things in the microwave, just to see what might happen. In his home state of Tennessee, his most famous experiment involved a bar of Irish Spring soap, which quickly turned into an abominable monster when the microwave button was hit. The experiment, described to hundreds of scientists at the Lunar Advisory Group, involved the transformation of regolith. He once put a small sample of lunar soil brought back by Apollo astronauts into a microwave. Taylor found that it melted within 30 seconds at only 250 watts. And the reason why it melted so quickly has to do with moon dust composition. It's produced from the constant bombardment of micrometeorites. As these micrometeorites slam into lunar sand and rocks at incredible velocities, they melt and form incredibly small glass shards. The glass contains nanometer scale beads of pure iron, so-called nanophase iron. Those tiny iron beads efficiently concentrate microwave energy, causing the beads to sinter or fuse the loose soils into large clumps. Taylor's observations have led him to imagine all sorts of machinery that could be sent to the moon and then used to fuse lunar dust into useful solids. If we take Taylor's example of a buggy pulled behind a rover that is outfitted with a set of magnetrons, the heating element in a microwave oven, with the correct power and microwave frequency, an astronaut could effectively drive along the lunar surface, sintering the soil as they go, melting and fusing the regolith into brick up to half a meter deep. And if the astronaut increased the power, they could potentially heat the regolith to such a degree that it would create a glass road. Taylor goes on to describe the process of turning craters on the moon into natural radio telescopes, similar to the Arecibo, a 305-meter diameter telescope formed from a natural circular valley in Puerto Rico. All this by using microwaves like lawnmowers to sinter the regolith into a smooth surface. All it would need is an antenna. Still, many technological challenges remain before Taylor's ideas can be put to the test. Sintering regolith in a microwave on Earth is completely different from doing it on the moon. For one, the moon has no atmosphere. The idea has promise, however, using the lunar surface to our advantage as we explore, creating landing pads, roads, building materials, and even radiation shielding with this sintering technique. Taylor suggests that our only true limit is our imagination. But even if sintering moon dust is viable, there remain other risks. Astronauts will have to land on the lunar surface before any sintering can be done, and they'll be exposed to moon dust when exploring the surface, even while using one of these proposed microwave lawnmowers. And there are the potential adverse health effects of inhaling this stuff. Harrison Schmitt said that the lunar module smelled like gunpowder when he sniffed the air. His commander Gene Cernan agreed. Lunar dust resembles silica dust on Earth, which causes silicosis, a terrible disease. Silicosis is formerly known as stone grinder's disease, which first came to public knowledge during the Great Depression when hundreds of miners in West Virginia died within 5 years of breathing the fine quartz dust kicked into the air by their drilling. And they had only been drilling for several months. This was one of the biggest occupational health disasters in U.S. history. Now, that isn't to say that astronauts will definitely get silicosis if they return to the moon, but it is a possibility we can't take lightly. If we're to return to the moon, we need to be able to provide adequate protection for our astronauts' lungs. Then there are the risks to machinery inside lunar modules, vehicles, computers, and the suits themselves. Among ideas proposed for protecting vital mission equipment include improved ventilation with magnetic filters, magnetic traps under floor grates, air showers, vacuum cleaners, dust covers, dust repellent, as well as magnetic wallpaper, and many more potential technologies. I don't know about you, but I could use some magnetic wallpaper here. What's amazing about how we're facing these challenges, though, is that by solving them on the moon, we may be paving the path to exploring the rest of the solar system, other logistical and technological problems notwithstanding. I hope you enjoyed that video. We've got many more coming in the coming weeks. I am Eric Malachite. Be sure to hit that like button, that subscribe button, and ring that bell for future content. And I'll see you next time on Science Get.